Hello and welcome to your video on topics 4.7 through 4.9. We're going to be covering solar radiation in the Earth's seasons, Earth's geography and climate, and then El Nino, excuse me, and La Nina. All right, so the very first question that you're given wants you to understand the difference between weather and climate. And this paragraph right here is very helpful with that. That weather is a set of short-term atmospheric conditions, whereas climate is the general pattern. Mark Twain had a saying about this, which was very good, I guess, for lack of a better term, which is this. Climate is what you expect and weather is what you get. So climate is what hundreds of years of data tells us should happen that day, and then weather is the thing that actually happens. When we start talking about things like climate change, you're going to see the reason we call it climate change is because historical patterns of weather no longer apply. Okay, what are the two main factors that account for the variations in global climate? We have down here, the first is the cyclical movement of air driven by solar energy. This is a form of convection. You already know that. Air is warmed by the warm earth and also by the sun, and it rises, and as it rises it cools and falls back down. Now remember, the reason that it rises and cools is not because of the heat. The heat drives the particles apart, which makes the air less dense, which is why it rises. Okay, do remember, it's not just the heat causes the reduction in density, which then causes it to rise. So please make sure that you keep that it's not just warmer and cooler, it is warmer and less dense, and then cooler and more dense. So that is one of the things, the convection cells. And then the second major climactic factor is right here, uneven heating of the Earth's surface by the sun. This is really key. I don't know if you've ever thought about it, but wonder why it is that the temperatures are so much warmer and more constant at the equator than they are at the poles. It is not that the sun is stronger or less strong in those different areas. It's all about unit areas. So there is a term, which I'll get to in just a second, called insolation, that's going to explain this in a second. So anyway, those are the two topics there. Side note, I apologize for the quality of the light. I should have brought an extra lamp in here where I'm filming, so just do the best you can. All right. What are 5 main factors that help to determine regional climates? Well, obviously right here we have, I don't know where that part is. One second, let me just flip ahead. Okay. So I messed up a little bit. Sorry about that. Climate varies. Here are the two main reasons right here. So back up. Climate varies because of global air circulation and ocean currents. Okay, so those are the two main ones. So I apologize. Back up. I was wondering why it was I was continuing to explain the air. It would help if I actually reread the passage, so I apologize for that. So let's back up and look at number 2 again. What are the two main factors that account for variations in global climate? It's going to be air circulation and ocean currents. This ocean current is actually pretty important. I don't know if it's going to be brought up a little bit later on, but I'm going to talk about it right now. This right here, this Gulf Stream, picks up heat, as you can see, it near the equator, and it carries it by Florida and then shoots all the way over here to Europe. This is the reason why Europe is warmer than expected. When you look where it is latitude-wise, it's right up there with parts of Canada, and yet it's still reasonably lovely in these upper regions as compared to over here, and it's because of this warm water current, which is again why the climate here is warmer than expected. If this ever shut down, if that current ever stopped moving, this would be plunged into a little ice age. Most of Europe would. Okay, so now let's go ahead and go back to the 5 main factors that help to determine regional climates. Convection. We're going to talk more about the 6 convection currents. I don't know if they're not named in here. We're going to name them specifically in class. So again, regional climates, that's going to be air convection currents. Remember, there are 6, 3 above the equator, 3 below the equator. Although they're not all named, they're all right there. Okay, so there's 3 above and 3 below. And you know that the 2 right here are the Hadley cells, right around the equator. Okay, so you have regional climates determined by air convection currents, which also determine, if you notice, rain as well. When you look back at this graphic that I just showed you, you can also see where rain occurs. Please do make sure that you not understand where the currents are, but in which way they flow and where they bring water to and where they suck moisture away from, because it's important to know on a test, not on the quiz, but on a test for sure. So second is uneven heating of the surface of the sun. I'm going to talk about insolation here in a second. Remember that latitudes go this way and longitudes go this way. So please be familiar with that. We are going to be focusing on the latitudes at 0 degrees, at 90 degrees, and then at 30 and 60 degrees. If those sections sound familiar, they should, because if you have 3 convection cells above the equator and 3 below, you can see that they butt up against each other every 30 degrees. Watch out. All right. So the second, okay, again, uneven heating, sorry about that. Okay, here's what insolation is, since we're on this right now. Insolation is the input of solar energy in a given area, and this is where you need to go ahead and look at this. If I get to it, I'll do a demo in class too. The sun is the sun. It radiates its energy in all directions, and it's uniform. So how come it is hotter here than it is up here? And the answer is it's the tilt of the Earth, because here at the equator, it's hitting directly. So same amount of energy, smaller unit area. So if it's smaller unit area, it means it's more concentrated per unit area. Now, imagine that same energy spread across a larger area. That is why it is colder up here. Same energy spread across a larger area because of the curvature of the globe and also because of its tilt. Again, if this is tough for you to picture, I'm going to be showing you using a flashlight in class of what I mean. All right, so third major factor, again, is the tilt of the Earth's axis. There is, I don't know if I've posted it yet or not, I'll have to go back and check. There is a short video on Harvard students who are asked why it is that we have seasons, and many of them, graduates of Harvard, say it's because the Earth gets farther and closer to the sun. If that were the case, why is it that the seasons are opposite in the other poles? The answer, it's precisely the tilt. Okay, so it depends where you are in the rotation as to whether or not you're tilted towards the sun or away from the sun as it makes its annual rotation. This also explains why it is that the equator always gets the same amount of sun, because it's tilted towards the sun at the same angle all the time. Okay, so again, we have convection cells, we have uneven heating, which is due to insolation, which is also due to the tilt of the Earth's axis, and then the rotation of the Earth on its axis. I mean, if you think about it, the Earth is spinning at the same rate. So that means that the speed of rotations up here is going to be slower than the speed of rotations here, because it has to cover, it has to make one full rotation in one day, okay? But if you were to take the circumference of a circle here versus the circumference of the circle around the Earth's axis, it means that, it's like, think about your nose and your belly button. Your nose probably is going to spin at a faster speed than your belly button, because the circumference of your waist for most people is larger than the circumference of your head where your nose is. So kind of tough to keep in your mind, but just realize that that's the case. Now, why do we care? And that means air masses moving to the north or the south from the equator are deflected to the east because they're also moving faster. Because think about it, the globe is spinning under the atmosphere, but it's also influencing the speed at which the atmosphere moves. That deflection is called the Coriolis Effect. Okay, why do you care? This is part of what causes weather patterns. If the Earth was not spinning, we would not have the weather patterns that we do. It also, small things, birds that migrate from north to south have to take into account when they fly the rotation of the Earth underneath them. Planes that fly have to do the same thing. If you want to launch a missile, if you want it to hit the right place, you also have to take into effect that the Earth is going to be rotating underneath that missile as it moves. So, but for all intents and purposes here, it is this Coriolis effect which influences the how fast the atmosphere is moving, which causes imbalances, which is basically wind, and that can blow moisture in different places and also heat in different places. If you can't tell, your understanding of all of this does not have to be meteorologist good. You just need to be able to explain these in an adequate fashion. All right, so we've got, again, this plays into the convection cells. They're all kind of interrelated, which is also helpful. And here it is again where they name the Hadley cells. This also explains the directions of the winds. Remember we talked about trade winds and westerlies and whatnot? And these are caused by the Coriolis effect. All right, so winds and winds and winds and winds. All right, and the fifth major factor is going to be the ocean currents. They help to redistribute heat from the sun. If you've had chemistry, you know that water has a high specific heat. For those of you who have not had chemistry, what that means is it takes a lot of heat input into water to make its temperature raise 1 degree. Why do you care? Water holds on to heat. That means that part of the reason why we have such an even temperature around our globe, and it is truly even, we do not have hundreds of degrees of fluctuation every single day like it is on other planets without water, is because our planet is mostly water and it holds on to heat. So that means while it heats up slowly, it also cools down slowly. It's one of the reasons why we in Fort Myers do not experience the wild temperature fluctuations that cities inland from us do. You know, although we are farther south, Orlando, as an example, has higher temperatures in the summertime, partially because they are not a coastal town. So they do not enjoy the stabilizing benefits of being close to water that helps to, excuse me, directly influence the our temperatures. All right, so again, the two major reasons for global climate are air circulation and ocean currents. Regionally, it's influenced by what specific convection cells are near you. It is influenced, which not only influences your temperature, but also your precipitation. Uneven heating, which is due to a concept called insolation, which is how much energy you get per unit area from the sun, the key being per unit area. Another one is the tilt of the Earth's axis, the rotation of the Earth on its axis, which leads to the Coriolis effect, which directly plays into the movement of air, and then why it is specifically that, ocean currents influence local weather. And again, specifically, do keep in mind that this specific current right here is part of the reason why Europe is warmer than expected given its latitude. And remember again, the reason that this water sinks and it gets to be cold and it's on the bottom of the ocean is because it is more dense. Not only because it's cooler, but because it has more salt. Water that is at the equator experiences evaporation, so then it becomes more dense because there's more salt per unit area. So as it's moving, it ends up sinking, and then it is in there. You have some influence from the sun. Water heats up and rises again. So please keep that in mind. Let's see. Do I have you? Which factor determines the seasons? Remember again, let's go back here. Tilt of the Earth's axis. Super important. I've just been talking, so let me just go back and make sure that we are... What is the tilt of the Earth's axis in degrees? Right here, 23.5. Understand that when it is winter in the northern hemisphere, it is summer in the southern hemisphere. Okay, super, super important. Let's see what else I talked about here. Do I have you define what a gyre is yet? No, we'll talk about that during... we talk about... That'll be in another unit. Just do realize, though, that some of these currents slowly create these circles, kind of like a slow-moving drain. They're called gyres. I'm not going to ask you about that. For this particular unit, just be aware that that word exists. Other factors are these things in here, the things like the Milankovitch cycle. This, I don't know, this is oddly specific. I don't necessarily see that this is going to be on the national exam. Just be aware that there are other factors. Why do these become important? Because people who like to argue against anthropogenic climate change like to quote these things. So just be aware that that those things exist. Align the 6 air convection cells with the general location of biomes. Okay, look at this again. You can see, again, the way that these cells rotate. It would help if I did it in the right direction. So if you have this warm air blowing across this land, it is also, because it is warm, it is picking up moisture. And because it is warm, it will start to rise. And then at some point it gets cold and it condenses and it rains. So you can see where these predictable cells of rain are here. Okay, that is why you have forests in these particular areas. Notice where the deserts are. Deserts are in general at 30 degrees above and below the equator, because as you can see, these two cells have warm, dry air blowing away and against that land, causing evaporation to occur, meaning that not only is there no rain available, well, sometimes there is, but most of the time not so much, it is also removing moisture from those particular areas. So where you see, the reason why you have the weather patterns that you do is because of the things that we talked about. If these convection cells shift for whatever reasons, you are going to see biomes shift as well. All right, at what latitude are hot deserts? I already talked about that. Okay, so that's 4.7 and 4.8. So topic 4.9 is El Nino and La Nina, and I will tell you that this is one of my weaker topics, but it is one that is popular on the national exam. So the first thing to realize is that ENSO, E-N-S-O, is a way that sometimes El Nino and La Nina is referred to as. So, so I'm just trying to see where this begins. Okay, so it begins right here where it says every few years normal wind patterns in the Pacific Ocean are disrupted and this affects weather. And it is called the El Nino Southern Oscillation, or ENSO. So, kiddos, when you go to write about this in an FRQ, if one appears, this is a Pacific Ocean only event. This is not an Atlantic Ocean thing, which means that countries on this side of Africa, these European countries, are not affected by this, okay? It is largely going to be things in the Pacific Ocean area. Yes, there are some areas in the United States that are affected, but it's largely because the United States is skinnier than the Eurasian continent here, okay? So these guys do not feel the direct effect of the El Nino Southern Oscillation. The areas that are going to feel some of the more immediate effects are going to be in this area right here. So this... The reason it's called Southern Oscillation is the actual event occurs below the equator in the southern hemisphere. Okay, so the first thing you need to do is get it in your brain where this happens. This happens between the coast of the western coast of South America, and then the eastern coast of Australia, and all of the Indonesian islands that are in here. Side note, if you haven't started to become familiar with where some of the main players are in terms of countries and continents, get yourself a map and start to figure it out now, because on the national exam, maps are not going to be labeled necessarily. Okay, so you've got it in your head that this is what happens. There are some normal patterns. So let's go ahead and talk about the way that things normally are. Normally, you have a winds at the equator blow in this direction, meaning that warm water is pushed to the west from South America to Australia across the Pacific. What does that mean? That means that as this water gets pushed this way, it also means that underneath the water is then pushed in the opposite direction. Why do we care? Because nutrients at the bottom of the ocean along the Australian continent are then pushed across the Pacific and end up hitting the South American plate. Well, there's more than one plate over there, but South America, and then pushing up, creating an upwelling. Why do we care about that? Because this means that you have a lot of fish that feed in this particular area right here. Now, another thing that happens is again, the winds are going this way, so that means it sweeps across the Pacific, and it is warm, so it's picking up all this moisture, and then it rises, and as it rises, you have rain. Okay, so that means that you have, what are normal conditions? Normal conditions are, let's see if your book describes them. Right. Okay, so anyway, it's normally rainy over here and dry over here. So those are normal conditions. And then you also have this upwelling going on. All right, so every few years, and the reason it says few years is it can be 3 to 5, it just depends. And why do I say it just depends? Because we don't understand all of the factors that play into this. So the reason it's called El Nino is that means the child. This usually happens in December. Okay, so for whatever reason, the winds go in the opposite direction. Okay, so this is another big thing. So now the winds are going this way. All right, why do we care? Because this then basically shuts off this upwelling. That means the fish are no longer here. Now, what are some other things that happen? During El Nino, weather patterns are flipped. So that means that places that are normally wet are dry, and places that are normally dry are wet. So that means, now, why would you care about getting, oh, because we think here in Florida more water is good. Well, if you're not used to having dry conditions, it means that your soil and your plants are not used to taking in a lot of water, which means you can end up with things like mudslides. And then again, if you have plants that are depending upon this December rain and they don't get it, you're going to die. The plants are going to die, but that also means you have an increase in fires and whatnot because you have all of this dry vegetation that's over here. Okay, so all of this is explained right in here. And then what's really interesting is, although these guys don't experience it, look at how many other folks experience it. So all of these areas in here experience drought. You have unusually high rainfall. Even you can see the state of Florida experiences some of that. And then unusually warm periods over here. So I can't say one thing is less important than the other. So be aware of the global influences. But the biggest thing to realize about El Nino is this. Fix in your mind the way that the weather normally looks in this upwelling. Then say to yourself, when El Nino occurs, everything is opposite. Wet places are dry, dry places are wet, and this upwelling shuts off. Now again, the animals who depend upon these fish can theoretically go other places to find them, but the fishermen who rely upon these fish as their livelihood, that is a human impact of El Nino. You know, other human impacts are, you know, fires impact people and floods impact people. You know, again, keep in mind in this class you need to know about environmental factors, impacts, and also impacts on humans. You can see that it can raise the global temperature by almost 1/2 degree for an entire year or two. And when you combine that with things like climate change and then overuse of water leading to droughts in normally dry areas to start with, you know, it can all turn into this kind of confluence of events that can create problems. And then you can see here, it can even become something like a super ENSO, and you know, 23,000 people died. All right, La Nina is where basically normal weather patterns become the wet places become wetter, the dry places become drier, and the stormy places become stormier. So all of the normal weather patterns, just think when you're doing this. And again, we don't know why this happens. We can kind of predict when they occur just because we know the general time frame, but we can't say for sure until after they've happened and we're like, oh, that was El Nino or La Nina. Okay, I think I have covered, let's see. Differentiate between tornadoes and cyclones. Okay, this is not tough. Tornadoes are over land and cyclones are over the water. That's it. All right, so where are tornadoes most common in the United States? They're going to be in the windiest parts of the United States, which are going to be our grasslands. So that's going to be in the Midwest. That's also where we grow crops, just as a reminder. Let's see. And then what is a gyre? I knew I had it somewhere. So a gyre is a circular pattern of a current which moves clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. This is going to become important when we start talking about something called the Pacific Ocean Garbage Patch, which is a subsurface patch of microplastic particles twice the size of Texas, I think, at this point. So anyway, and the reason it stays there is because of a gyre. Anyway, just for right now, just know what the definition is. Okay, so that takes us through the last 3 topics of material. So there you go.